Now we are going to see a brief introduction about Newton's interpolation formula. Before that, we can define what is called the interpolation. Interpolation is nothing but the estimation of values between well-known discrete points. In order to elaborate more, it is the process of finding the most appropriate estimate for the missing data. For making the most probable estimate, it requires the following assumptions. There are two assumptions. First one, the frequency distribution is normal and it is not marked by sudden ups and downs. Second one is the changes in the series are uniform within a period. Now we can explain a problem on the Newton's forward interpolation. So the problem is, from the following table calculate the value of stream table. The temperature and the pressure is given in the table. The temperature is defined from 140 to 180 taking 10 degrees Celsius. Pressure is given as some decimal points. We have to find the pressure at temperature at the particular points 142 degrees and 175 degrees. For this, first we can consider at t equal to 142 degrees. We use the forward interpolation formula. The formula is y of x equal to p4 of x, which is equal to y0 plus u divided by 1 factorial del y0 plus u into u minus 1 divided by 2 factorial into del square y0 plus u into u minus 1 u minus 2 divided by 3 factorial into del cube of y0 plus etc. Here u is the interval which is defined by x minus x0 the whole divided by h. Here we can consider x0 is equal to 140 degrees and our interval h is equal to 10. Now by applying these two x0 and h values in the above formula, we can calculate u as x minus 140 by 10 and thus it gives the value 0.2. Now we can draw the difference table now. So we can separate into 6 columns and 5 rows. Okay, in the first column, which is defined as x, we take all the temperature values here 140, 150, 160, 170 and 180. The corresponding pressure value is given over here. So for the corresponding y values, we can calculate del y here 1.169 by subtracting the first value from the second value. Likewise, we can calculate 1.448 by subtracting the second value from the third value. Likewise, we can calculate all the del y column here. Next, del square y. Del square y, the same procedure. We can calculate by subtracting the first value from the second value. That is 0.279 is obtained by subtracting 1.169 from 1.1448. Likewise, the other two values has been got. Likewise, we can calculate del cube y and del power 4y by the same procedure by subtracting the first value from the second value. Now, we can apply all these values in our formula which is explained earlier. Y of x equal to, which is already be explained, p4 of x equal to, which is explained. So first value is y0. So this value is given here. All these values according to the formula is written over here. So we can calculate by using calculators. By calculating likewise, we get the y of x value as 3.899. Next, the another point we have to calculate is after t is equal to 175. So we use backward interpolation formula for this one. The formula is thus explained. Y of x is equal to p4 of x, which is equal to y4 plus v divided by 1 into nebula y4. Here why? Because we are using the alphabet v means we have already used the alphabet u for the forward interpolation formula. Thus we are changing the variable from u to v here. plus v into v plus 1 divided by 2 factorial into del square y4 and plus etc. Like the above forward interpolation formula, we can explain this as backward interpolation. Here v is given as x minus x4 divided by h. Here x4 is equal to 180 and x equal to 175 and the interval gap is h is equal to 10. By applying all these three values here, we can calculate v equal to minus 0.5. So by applying all these values in the above formula, this formula, we are going to use all these values in this formula. We are getting y of x is equal to p, which is equal to p4 of x, which is equal to 10.225 plus minus of 0.5 divided by 1 factorial into 2.149 plus etc. So this way, if we are putting all these our calculated values in the tabular column, if we put in the formula, we get the final answer as 9.1004844375. So we have, as we earlier said, we have explained the Newton's forward interpolation formula as well as backward interpolation formula for two different values of temperature.